Okay, welcome back. This is lesson 3.4. I'm just going to review a little bit of what we've been talking about. We have talked about prototypes in JavaScript, talking about classes and objects and inheritance. We'll talk more about that in the future. We also, I think back in video 3.1 or 3.2, we created a vector class, and we talked a little bit about vector math, prototypes, and classes. And then we're going to talk about path following. We've already introduced the idea of location, acceleration, and velocity. One of the key things that we'll need to cover is how do we use those three things to go from one specific point to another specific point. Today I thought we'd go ahead and start the process of doing path finding. And path finding is a process of moving from point to point, or more specifically moving from a starting point to an end goal, avoiding any obstacles along the way. There's different algorithms for this. We'll look at a couple, but the one we're going to use for our game is called goal-based pathfinding, and so I'm going to start talking about that one today specifically. Okay, so we're going to start a pathfinding project right now, and the first step in doing this is we're going to have to set up some kind of grid. And the way that I'm going to do this is I'm going to create a grid of cell objects, and these cell objects are going to have, let's say, a starting location and a goal. And no matter how I block this off, let's say I come in here and I'm just randomly blocking off various cells, no matter how the cells are blocked, as long as they're not blocked off completely, the enemies should be able to find their way around this. So they'll find some path to get to where they're going, and ideally they'll find the shortest path. But that's where we're going with this. And we'll look at a couple of different algorithms through the course of the next 2 or 3 videos, but the main thing is right now in this video we're going to create a grid of cell objects, and each cell objects will be loaded into a 2-dimensional array, and they will have an ID and they'll know some information about themselves. They'll have just a location vector. We're going to be able to render those, and so let's go ahead and get started. Okay, this is where we left off in video 3.2, I believe. We had created an enemy class, and the enemies are moving now with 3 vectors. They have a location vector, a velocity vector, and an acceleration vector, and we added gravity. And so what we're going to be doing in this one is we're going to be moving into making this grid. So that looks like this. Okay, so in this video we're going to simply add this 2-dimensional array of cell objects in JavaScript, and we're going to render those to the screen. Every time I run this or hit the reload button in my browser, I notice I get a different set of occupied cells. So we'll be sending enemies from cell 1. The goal is going to be down here to cell, I guess it's 1080 something, and or maybe 1080, and then they're going to be able to find their way and move through these obstacles no matter how I draw them. Right now I think I have it set at about 10% occupied. I could set that equal to anything I want, and so this is just going to be good for testing experiences. Obviously in the run of the game we are not going to have these cells showing. We're not going to draw the grid, but this is going to be working behind the scenes so that we'll have this way of moving things around my map, whatever kind of tower game we want to come up with. And that's what we're getting to at the end of this video. Okay, so to start this off, I'm going to go ahead and open up my, I'm going to open up my tower class. Tower class is one of the last classes I made. Let's go ahead and split this left so we can see them both at the same time. So I've got my tower, let's see, my game class over here. And what I'll do is I'll just simply go into this tower, and I'm going to say file, and I'm saving it as cell.js. Okay, and I'll just make sure I go ahead and say cell here now. So I'm going to make a cell class. I'm going to use the term class. We went over the fact that there are no classes in Java, but we're using this sort of syntactic sugar. So I'll refer to these templates as cell classes, or whatever class we're happen to making. Anyway, I'm going to be making cell objects from this class. And so first thing I want to do is make sure I have that added into my index. And so if I come into my index, I need to make sure I've got my tower here, so right below that I'll simply copy that and paste that into my HTML, and I'll change this guy to cell.js, and so now I'll be able to see this. And so now my cell object is ready to go. The first thing I need to ask myself is, what does a cell need to know about itself? And clearly it needs to know location. It doesn't need an angle, it doesn't need visible, doesn't need any of these things. Those are all tower method properties. But I do need to pass in some parameters here. And I think to start off with, I'll pass in, the game object itself. I'm going to pass in an ID, and I'm going to pass in, let's say, C and R for column and row. And I need to know what those things are. And so when I create this guy, I'm going to go ahead and say it's going to have a location at CR. Now that's not quite enough. I'm going to have to multiply this by the number of pixels representing the width of each of these cells, but let's go make that in the game. We'll come back here and edit this later on. Also, I need to change update and get rid of update and checkfire. I think these guys aren't going to be changing during the run of the program, so they just need to be drawn once. And then in terms of update, I don't even think I'm going to need an update function or a checkfire function. We do need to be able to render this, and so I need a different kind of rendering. We're not going to be rendering towers, we're going to be rendering cells, but that's what I'm going to need. I'll need a couple of other methods in here later on, but just to get us started for this video, I think that is going to be enough. Okay, now let's go over here and say inside my game, I'm going to need an array of cells. I'm going to call this guy grid, because it's actually going to be a two-dimensional array, and so we do this quite differently than we do in Java. So I'll just set this up initially as a one-dimensional array, like so. And now I need to create some other properties down here for this. I'm going to do it after I set up the canvas, but what I need to do is I need to get some cell dimensions and so forth. And so let's say cell values here. And I need several things. Oh, I need two L's here. I need several things here. The first thing I need to know is what is the cell width. So I'll say this dot cell width is going to be something. Let's go ahead and start it off at 25. And now I need to know the number of columns and the number of rows. And so this is going to be a function of the size. Since I know my canvas has a width of 900 and a height of 750, I'm going to have the number of columns have to fit into the width and the number of rows have to fit into the height. And so the way that I can do this, I can say this dot num columns is going to be equal to this dot let's see, CNV, that's our canvas, dot width, and I'm simply going to divide that by the cell width. And so, for instance, if I have 100, if I have, let's see, 900 divided by, let's see, 900 divided by 25 is going to give me 36. And so that means there's going to be 36 columns. I'm going to do the same thing for the rows. And if I come over here and I say the number of rows is going to be very similar, it's the canvas height divided by cell width. Since the cells are square, I can have cell width and cell height as the same value. In any case, let me put a couple of semicolons in here and save that. And so now I know the dimensions. And if I were to log this, for instance, let's go ahead and log in number of rows. So if I take this dot column and I'm going to run this guy, let's see what I get. So I'll come back and reload this. I'm going to hit Control-Shift-I to go into my console, and I get 36. That works. And if I do the same thing for number of, I just did number of columns. I guess the number of rows is going to be how many times 25 goes into 750, which should be about 30, I think. Okay, any case, so let's go ahead and log that. Now, I need to create another method. So right after I load enemies, I'm going to say this dot load grid. So again, my grid is this thing that's going to be filled with cell objects. And so I think I'll go right above load enemies, and I will create a function called load grid. So load grid is not going to take in any parameters. And I need to do a nested for loop. So let's go ahead and do columns. This is going to be the number of columns. So it'll be this dot num columns. I think that's what I wrote up there. And this is going to be C++. And then I'll do the same thing for row. However, before I get there, the way that we make a two-dimensional array is I need to take my grid, and so my grid is simply an array of we don't know what yet, and I'm going to simply say grid dot, actually this dot grid, sorry, this dot grid dot push, and I'm going to push in a new array, and I can just go like that, and now I'm ready for the other part of my nested for loop. And so I'll simply take this guy, add him down here, and I'm going to say R is equal to 0, R is less than number of rows, and R++. And so each time I come in here, I'm going to push in a new cell object. And so for that I can say this dot grid, and I'll go ahead and look at grid element C, and I'm going to go ahead and push in a new cell object. So I'll just simply say new cell, and I have to think about the parameters that are going into that. It's going to, I wanted to pass a reference to the game, and then I'm going to, since I'm in the game class, this represents the game object. I need an ID, so maybe the best way to do that would be to come up here and say var count, and I'm going to set it equal to 1. I want the first guy to have an ID of 1, and I'll simply come in here and say count++. So the first one will get 1, and then it'll automatically increment count to 2, and so forth. And then finally, I need to pass in C and R. So if I come in here and say C for column and R for row, I'm ready to go ahead and give this guy the information he needs. And when I'm done with this, I should have an array of cells. Let's go ahead and down here and log this guy. This, by the way, was C. So I made sure I have R, 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 and C, C, C. So, and then down here, I want to log this. So let's log the grid. So I'll just say this dot grid. Okay, good. So let's see if this is working. If I come back over here now and I reload this, I see that I have an array of 36 elements, but each one of these guys is empty. Okay, so that's not working. It's getting the outer loop is working, but the inner loop is not. So let's see what's going on here. I have number of columns and number of rows. This looks right, this looks right, that all looks fine. Let me go ahead and make sure I don't have a typo up here on top. And if I look here, I have, let's see, number of columns, number of row. So save that. Let's go back here and run it again. And this time I have an array. Okay, so I have an array of 36 elements, and each of those array has 30 elements. And so that looks like it's, and these are all cell objects. And it has a location vector, so it looks like this is fine. Okay, so now I want to render the cells. To do that, I have to write a render function over here in the cell class. And over here where I'm rendering inside this run method, where I render the towers and the bullets and the enemies, I just commented out enemies here because I don't want to be seeing them while I'm looking at the grid right now. And so what I need to do is make a for loop. And I think, actually, let's do this. Let's just grab the code from right down here, load grid. It's basically going to be very similar to this nested for loop. We'll make a couple of quick changes, but I've already got the bound set up on this. So C goes from 0, C is less than number of columns. That's good. I don't want to be creating a new array. I already have my two-dimensional array set up. So basically I have an array, and each element in the first array is a pointer to another array which is containing cell objects. And that's how I get a two-dimensional array in JavaScript. But in any case, at this point, I'm not going to be pushing in new elements. What I want to do here is I want to go ahead and go to each element, and then I will simply call a render method. And if I do that, then I should be able to come over here and create my render method. Okay, so to create the render method, I'm going to have to put in some things here. I think I'm going to go ahead and just set up a couple local variables. I'm going to say this dot game is equal to game. So I've passed in a reference to the game object itself, and I think I'll get the context the same way. I'll say this dot ctx is equal to game dot context. And so now I have access to the context methods, which I'm going to need in order to do this rendering. So I've got this guy. I also need to multiply column and row. So let's go back and think about how we did this when we found the number of columns and the number of rows. To do that, we took the cell width, and we just took the the width of the canvas, divided that by the cell width, and that told us how many columns we were going to have. And we took the number of rows. We found the number of rows by taking the canvas height and dividing that by the number of cells. So we're going to do kind of the similar thing over here. We're going to take kind of the inverse of that, and we'll take C, that's the index location on this two-dimensional grid, but we need to get the width in the cell. And so if I multiply this by game, actually this dot game dot, let's see, cell width, that's going to locate this guy at the proper location. And I'll do the same thing for R. And so instead of moving over 1 pixel every time, I'm going to move over the width of the cell times whatever that is. So in any case, that's important. And let's see what else we need over here. We've got game. We've got game context. I'm going to need the game context in order to do my drawing down here. And so let's see, let's go ahead and put that in. So I've got this got context, CTX. I need a stroke style and a fill style. So fill style, and that's going to be equal to a string, and that's probably going to be something like, let's do something light, like, I don't know, let's do 002233. And we also need a stroke style, and that should be something dark. So let's do stroke style, and let's do FF. Oops, sorry, that's not light, that's dark. Let's do 112233 here, and up here let's do AAEECC. Okay, so that's going to give me my fill style and my stroke style. And so this is going to be a light color, this will be a darker color, and then I need to go ahead and draw my rectangle to use fill rect and stroke rect. And so fill rect is going to fill a rectangle, stroke rect is going to give me the outer line, and so is this dot location dot x and y are the upper left hand corner of each of these cell objects, and then I've got this w, and what I want to do then is go ahead and say this dot w is equal to game dot cell width. So back in the game object I have a cell width, I'm setting it equal to w, and so I can use that to draw each of these rectangles. Let's see if this works. And I've got several errors. Cell width. Well, let me go ahead and debug this and see what the problems are, and then we'll come right back. Okay, so I made kind of a silly error here. Notice I have game coming in here, but I don't actually set this dot game until the line after, and so this dot game, we don't know what this is here, so I can either erase the this dot, which I think will do, that sounds like the easiest, or I could have just moved this line of code down below this one, and then this dot game would have been defined. In any case, that looks good. Let's go ahead and see what happens here. And that worked. Okay, so all I have to do now is add numbers to these and some occupied guys, and so that'll just take a second. I'm almost out of time for this video, so let's see if I can do this really quickly. I'm going to come back over here to my game class, and I think when I make a, let's see, when I make an object in this guy right here, I'll go ahead and add a little piece here and say, can I do it right here? I think I can. I think I can say this dot grid. And then I'll go ahead and take C and R, and I will simply say dot occupied is equal to true if something happens. So what I need to do is say if, let's go ahead and just use a random number, so I'm going to say math.random, and let's multiply that by 100, and if this is less than 10, go ahead and set that guy equal to true. I don't think I have an occupied guy over here in the cell class, so let's go over here and say this dot occupied. Every time I make one of these cells, I'm going to set occupied to false, so it will not be occupied, but 10% of them will be occupied. And now when I render this, I can simply add a little piece over here, and I'll say, let's see, I need fill style, so I'll say if this dot occupied. Then I will go ahead and render it one color. Else I'll render it another color. And so to do that, I will take this guy. So this is the light color. So that's what I want if it's not occupied. If it is occupied, I'll go ahead and change it to something darker. And so I think that'll do it. So I'm setting it equal to occupied over here. Occupied equals true. And so if it is occupied, I give it a dark color, else I give it a light color. So let's go ahead and take a look and see if that works. Okay, good. So now every time I run this, I'll get 10% of these guys will be occupied. Of course, I can set that to whatever I want. The last point is I wanted to put the ID number in here. So let me just go ahead and paste that code in. Okay, so now I want to come in here. I've got my stroke style, fill rect, and I want to put some text in here. So right in here, I'll go ahead and say, these are again context methods. So I say this.context, and I'm going to choose a font. I chose 11px. I'm going to choose a fill style, which is black, and I'm going to choose fill text. So I'm just going to take this.id. So the way this works is I need a location. So I'm taking the location x, then the location y, and I don't want it to be bunched up right in the corner, so I'm simply adding 5 to x, adding 15 to y. If I save this now and come back and run this guy, I'll notice that I have undefined. Why is that? Let me check that real quickly. Running out of time here. This all looks good. This .id, do I have an ID? I do not have an ID. That's silly. Oh my goodness. Okay, so this .id is equal to ID. And so now if I run this again, I get numbers. Yay, okay. And so starting over here with 1, 10% of these guys are filled up. And I am just over 20 minutes, I think, so I'm going to go ahead and stop the video here. The next time we come into this, I'll go ahead and start figuring out a way to do the goal-based pathfinding. So this is my start. I'll describe the goal-based pathfinding. There's 2 things that we have to kind of accomplish. Actually 3. We have to get, for each cell, we have to know its neighbors. We have to assign each of the neighbors a number. And then we have to assign vectors. We'll talk about that in the next video. That's it for tonight. Bye-bye.